Dear students, are you ready for today's class? Okay, very good. In the last class, we have discussed regarding the physical properties of metals and non-metals. Okay. Today we will discuss the mainly chemical properties of metals and non-metals. What are the important chemical properties and what are the difference between metal and non-metal on the basis of their chemical properties? Today we will discuss. First, the first property, that is action with oxygen. Action with oxygen. We know that metal, when reacts with oxygen, produce metal oxides. Metal with oxygen always produce metal oxides. Similarly, non-metals with oxygen produce non-metallic oxides. These are the two important difference between metal and non-metals. That metal with oxygen produce metal oxides and non-metal with oxygen produce non-metallic oxides. That means this is both are producing oxide. But what is the nature of metal oxides? Pure metal oxides generally basic. This is the difference. And here non-metallic oxides mainly acidic or neutral. These two. Most of non-metal oxides are acidic and metal oxides are basic. These are two differences between the oxides of metal and non-metal produced by the action of oxygen. Let us take some examples. I will show you one activity that you see. You see that what activity? This is what? Burning of sodium metals. As sodium is very reactive towards oxygen, then what happens? This sodium with oxygen on heating produce sodium oxide and it bonds with yellow flame. That yellow flame that we observe due to formation of sodium oxides, and that sodium oxide is white. The substance will be white and yellow, it bonds with yellow flame. Sodium bonds with yellow flame and produce white sodium oxides. Similarly, magnesium metal, magnesium ribbon when bound with oxygen producing what? Magnesium oxide. This is forming magnesium oxide. This is also white ash. Formation of white ash. It burns with illuminated light. Okay? Let us give one example. This is your magnesium ribbon. This is your magnesium ribbon. Small strip of magnesium ribbon. And before heating magnesium ribbon, it should be rubbed clearly to clean the coating of magnesium carbonate or magnesium hydroxide present on it, so that it can easily burn, it will catch fire easily. So you see, when it will be heated, I am heating this ribbon, easily caught fire. It will take some time, 1 minute more. Now see, it is burning now. Just it is burning. During burning, a bright illuminated flames comes out with the formation of that magnesium oxide, white ash. So, and this is the main difference between two metals here. And if you see the non-metals, for example, burning of carbon in oxygen, forming carbon dioxide, already you know. When coal burns, produce carbon dioxide. Sulfur burns in oxygen, producing sulfur dioxide. Phosphorus burn with oxygen, forming phosphorus pentoxides, like this. So these are the what? Non-metals. These are the non-metals. When bonds with the oxygen, reacts with the oxygen, forming non-metallic oxides, carbon dioxides, sulfur dioxides, phosphorus pentoxides. These are the what are these? These are the oxides of non-metals, and these are the oxides of metals, and these are basics. Sodium oxide is basic, magnesium oxide is basic. So if you see the reactivity of metals, if you see the reactivity order, first one is potassium greater than sodium, greater than your calcium, greater than magnesium, then greater than aluminium, then zinc, then iron, copper, like this. So these are the what? Reactivity order. Potassium burns very faster with oxygen, then sodium. That means for burning of magnesium, already we have observed it requires more heat to burn. Aluminium, zinc, that's why for burning this, the amount of heat required is more. That means the reactivity decreases. This is the reactivity decreasing. Order of reactivity decreases. That is from potassium to copper. So these are the action of metal and non-metals with oxygen forming metal oxides and non-metallic oxides. All metallic oxides are basic and non-metallic oxides are acidic or neutral. For example, your carbon when born incomplete combustion forming carbon monoxides, that is neutral. These all are acidic, but this is neutral. So it may be produced acidic or neutral oxides, but metal almost produce what? Basic oxides. But some non-metals, from some metals, aluminium with oxygen forming aluminium oxides, it is amphoteric. What is amphoteric? Showing the properties of acidic and basic character. So some metal oxides are amphoteric. Example, Al2O3, ZnO, PbO, SnO. These are the oxides produced from metals by action with oxygen, but these oxides are amphoteric. But almost reactive metals, sodium, magnesium, potassium, they produce only basic oxides. And non-metals, almost non-metals produce acidic oxides, exception, one example is carbon monoxide, which is neutral. So these are some important properties of metal that with action with oxygen. Okay. Second properties is action with water. Okay. You remember this thing. Metal with water produce metal hydroxides and hydrogen gas. Some cases, some metals reacts with water, produce metal oxides plus hydrogen. So these are two important products of action of metal with water. Some very reactive metals always produce metal hydroxides, and some moderate reactive metals on heating or action with steam produce metal oxides. This is the difference. Very reactive metals with water produce metal hydroxides, and some moderate reactive metals with steam produce metal oxides, and both cases produce hydrogen gas. So this is the very important. For here, non-metals with water generally no reactions. Non-metal does not react with water because it cannot displace hydrogen from water. Non-metal cannot displace hydrogen from water, that's why it does not react with water. But metal can displace hydrogen from water, that's why it can react with water, forming which gas? Hydrogen gas. Let us see one activity. I have taken water in the beaker. And I am adding what? Sodium to the beaker. Sodium metal. You see the reaction. Sodium is reacting with water because sodium is very reactive metal. Okay. It is not catching fire due to temperature, low temperature in water, but due to the very reactivity nature, it reacts continuously till the metal reacts completely with water. So this is the reaction of sodium metal with water. Okay. So what happens? The reaction takes place here. Sodium metals with water at room temperature. Here heat is not required. Produce sodium hydroxide and hydrogen gas. Here sodium reacts with water, forming sodium hydroxide and hydrogen gas. Hydrogen gas is released. Hydrogen gas is colorless gas, it is not visible, but the reaction is very fast reaction. Action of sodium metal with water. But some metals, what are the metals? Some metals like your aluminium with water. Water means steam. Here steam is react, not your water. In the form of steam and strong heating, it produces aluminium oxide and hydrogen gas. Similarly, iron with water, steam, like steam, produce what? Fe3O4. This is called ferrous ferric oxide plus hydrogen gas. balancing part you will do. So you see the difference. Very reactive metal with water at room temperature reacts and forming hydroxides. But moderate reactive metals like your aluminium, iron and zinc like this, it reacts with water. Water means that is steam, and on heating also. Without heating it not possible. Steam and strong heating it produce oxides, aluminum oxide, iron oxides. So these are the some properties of metals. But your non-metals already written. Non-metals generally do not react with water because non-metal cannot displace hydrogen from acids. That's why non-metal is not reactive. What are the reactivity order? What are the reactivity order? Reactivity order is same. Potassium greater than sodium, greater than calcium, greater than magnesium, greater than aluminium, greater than zinc, greater than iron, greater than copper. Like this. This is the order of reactivity of metals towards water. Okay. Next, third property we will discuss. Next, third properties, that is action with acids. We know metal reacts with acid, produce salt and hydrogen gas. This is very important. All metals, that means reactive metals, that react with acids, produce salt and hydrogen gas. So this is very important property of metals. Metal reacts with acid, produce salt and hydrogen. But generally, non-metals plus acid. Acid means dilute acid. Dilute acid, generally no reactions. Generally, non-metals do not react with acids. Non-metal do not react with water. So these are the common properties of non-metals. But metals reacts with acid, produce salt and hydrogen gas. This is very important. The gas is hydrogen. You see one activity that in this test tube I have taken dilute acid I have taken, then now I am adding which zinc metals. This is zinc metals I am adding. You see the reaction. You see the vigorous reaction, very fast reaction taking place between zinc metal and hydrochloric acid. The reaction is very fast and forming hydrogen gas. The gas, this is not hydrogen gas really, this is the vapor of water producing and HCl also producing due to heat, but the gas hydrogen produced is not visible. And this effervescence, formation of hydrogen gas taking place. So this is the reaction of zinc metal with hydrochloric acids. Okay, you see the reaction. And what are the equation? Equation is like this. We have taken zinc metals and concentrated hydrochloric acid. Then the product is salt, zinc chloride and hydrogen gas. You see, we have written metal with acid produce salt and hydrogen gas. And your acid is hydrochloric acid, salt is zinc chloride. Similarly, if you take zinc plus sulfuric acid, it also gives zinc sulfate and hydrogen. So, any acid, if you take, suppose a reactive, if you take a reactive metal, very reactive metal, sodium and hydrochloric acid, the reaction will be very fast, that is sodium chloride and hydrogen. So, this is the reaction of metal with acids. Some metals do not react with, that is copper with HCl, no reactions. Already we have read in types of chemical reaction. This reaction not taking place because this copper metals is a low reactive metals. It cannot displace hydrogen from acid. Which acid? Hydrochloric acid. That's why reaction is not possible. But these metals, zinc, sodium, potassium, magnesium, aluminium, they can react with your acids and forming salt and hydrogen gas. So this is the difference between this. So the reactivity order, that is called metal reactivity series, metal activity series. What is metal activity series? That means the decreasing order of reactivity of metals towards dilute acid. What are the order of reactivity? Potassium, then your sodium, then calcium, then magnesium, aluminium, then zinc, then iron, copper, silver, okay, this is silver, then mercury, gold, platinum, like this. So up to gold you write, this up to this, as per your textbook this is potassium, then gold. So potassium is the most reactive metal towards acid and gold is the least reactive metal towards acid. In between this, these are the low reactive, these some are more reactive, some are less reactive, but potassium is the most reactive metal and gold is the least reactive metal towards acids. And again I am repeating this thing, non-metal do not react with acids because non-metal cannot displace hydrogen from acids, that's why they do not react with acids. So these are the very important properties of metals and non-metals. Then properties 4. The next properties, that is action with base. Metal, some selected metal with base produce salt and hydrogen. But non-metals with base, no reaction. This is the difference between metals and non-metals. Metal react with base, produce salt and hydrogen gas like your acids. Non-metal with base, no reactions. I will show you one activity that you see. I have taken here sodium hydroxide solution, that is sodium hydroxide solution is base. Now I am adding powder aluminum. Powder aluminum I am adding, just you see the observation, reaction of you see the reaction. You see the reaction, very fast reaction, aluminum powder and sodium hydroxide. Very fast reaction taking place, very fast reaction between sodium hydroxide and aluminum powder. Metals also, some very reactive metals also reacts with base. Okay, so this is the reaction of what? Metal. For example, what we have taken? Aluminium metal with sodium hydroxide in presence of water, dilute sodium hydroxide. That's why I have written H2O, and the product is salt is NaLO2 plus hydrogen. What is the name of this salt? That salt is produced, it is settled down at the container. That salt is produced, it is settling down at the container. So this is what? This is the salt, the name is sodium meta-aluminate. What is the name of this salt? NaLO2, that is sodium meta-aluminate, and the gas is hydrogen gas is released. The gas is hydrogen gas. Similarly, other metals like zinc reacts with base, in which the product is sodium zincate, Na2 ZnO2 plus hydrogen. You see the difference. This is called sodium zincate. Sodium zincate. First one salt is sodium meta-aluminate, second one salt is sodium zincate, and produce hydrogen gas. But the reactivity of aluminium will be more than zinc. If you see the reactivity of aluminium will be greater than zinc. Aluminium with N base, the reaction is vigorous, very fast reaction. You have observed that thing. So this is the conclusion. But these metals are not very reactive metals. These selected metals, aluminium, zinc, what are the metals which react with your base? Aluminium, zinc, Pb, lead, tin. These metals, aluminium, zinc, Pb, tin, this type of metals reacts with base, forming salt and hydrogen gas. And non-metals generally do not react with base. So why? If question is asked, you write non-metal cannot displace hydrogen from base. Non-metal cannot displace hydrogen from acid. That's why they do not react with acid and bases. Okay? So next properties. Next properties, that is action with halogen. Halogen means, what are the halogens? Fluorine, chlorine, bromine, iodine. These are called halogens. The name of the group, that is halogen. Metal with halogen. Halogen generally written as X. That is called X. So metal with halogen X2. Diatomic form, that is produced metal halides. Metal halides. Metal with halogen produce metal halides, which is ionic nature. Generally, metal halides are ionic character. So metal with halogen produce metal halides, and non-metals with halogen produce non-metallic halides. Non-metallic halides. And non-metallic halides almost covalent. Covalent nature. What are the examples? For example, sodium with halogen chlorine forming sodium chloride. Similar example, zinc with chlorine produce zinc chloride. Aluminium with chlorine produce aluminium chloride. So formula of this is a salt. This is, you can say it is a salt. Metal halides means salt. So here salt is sodium chloride, here salt is zinc chloride, here salt is aluminum chloride. So like this, metal with halogen produce halides. Here halogen we have taken chlorine. You can take chlorine, bromine, iodine like this. With non-metals, similarly, suppose your hydrogen non-metal with chlorine, that is HCl. carbon with chlorine, that is carbon tetrachloride, like this. Then sulfur with chlorine, sulfur tetrachloride. So phosphorus with chlorine produce phosphorus pentachloride, phosphorus pentachloride. Phosphorus with chlorine produce phosphorus trichloride. So this thing on the basis of what? But both reaction require heat. Without heat, reaction is not possible. Both reacts heat. Produce forming. What is forming? These are non-metallic halides, and these are produced metallic halides. So these are and all non-metallic halides are covalent. These are covalent. These are covalent, and these are also covalent. Okay, so this is regarding metal with halogen forming metal halides, which is ionic character, and non-metal with halogen forming metallic halides, which is covalent. So this is the difference between metal and non-metal with the action of halogen. Okay, then next properties. Next properties, action with hydrogen. Metal reacts with hydrogen, produce metallic hydrides. Non-metal reacts with same hydrogen, produce non-metallic hydrides. What are the examples? Just let us discuss. Suppose sodium metal with hydrogen produce sodium hydride, and this metallic hydride generally ionic nature, and this is covalent. This is the difference for the nature of metal with hydrides and non-metal hydrides. Almost metallic hydrides are ionic, non-metal hydrides are covalent. So sodium hydrogen, sodium hydride, calcium hydrogen produce calcium hydride on the basis of valency. And for what are the examples of non-metals? For example, your carbon and hydrogen produce carbon anhydride. There are different examples. Carbon hydride, that is methane. Your hydrogen non-metals. Okay, hydrogen with chlorine, that is non-metal, produce hydro, that is one hydride. Nitrogen plus hydrogen produce non-metallic hydrides. So these are example of non-metal hydrides. NH3. Similarly, hydrogen with oxygen, you can say that is water. Hydrides of oxygen, you can say hydrides of oxygen. Here, hydrides of nitrogen, this is called ammonia. Okay, it is hydrochloric acid, that is methane. We see the difference.